Welcome to our module on backend development, where we will explore building robust applications using Node, JS and Express, JS. Our main goal is to learn how to build scalable APIs, specifically tailored for the MERN stack. Let us now look at the key features that make Node, JS a powerful choice for backend development. These features are essential for powering efficient and high-performing backend solutions in modern web applications. First, Node. JS serves as a JavaScript runtime environment, allowing you to execute JavaScript code outside of browsers. This enables you to use JavaScript for both front-end and back-end development, creating a unified language stack. It operates on an asynchronous, event-driven model, which ensures highly efficient and responsive operations for your applications. This design prevents bottlenecks, allowing Node.js to handle many operations concurrently without waiting for each to finish. Node.js utilizes a non-blocking I/O model, which is crucial for enabling high scalability when handling multiple requests. This means that I/O operations, like reading files or database queries, do not halt the execution of other code. Node.js is powered by the V8 engine, which is the same fast engine that Google Chrome uses for its JavaScript execution. This engine ensures that your JavaScript code runs very quickly, contributing to Node.js's high performance. Despite being single-threaded, Node.js effectively manages concurrent requests by leveraging the libviv library for its operations. This allows it to handle many simultaneous connections efficiently, making it suitable for high-traffic applications. Now, let us delve into the Node.js architecture in action, understanding its event-driven, non-blocking model. This section will clarify how Node.js processes requests efficiently, ensuring high performance and scalability. The process begins when a client, such as a user, sends a request to the server, perhaps an API call. This initial request is the starting point for any interaction with your backend application. Next, the Node.js event loop receives this request and quickly checks if it involves a blocking operation. The event loop is central to Node.js's asynchronous nature, managing the flow of all incoming tasks. For non-blocking I/O tasks, Node.js efficiently delegates these operations to a pool of worker threads. This delegation allows the main thread to remain free, processing other incoming requests without interruption. Once an I/O task completes, a callback function is executed, handling the results of that operation. This callback mechanism is fundamental to Node.js's asynchronous programming, ensuring smooth, continuous execution. Finally, the client receives the response to their request, all without blocking other pending operations on the server. This efficient response delivery highlights the non-blocking nature, allowing the server to handle many users simultaneously. Let us now get started with Node.js, covering its installation and how to execute your very first program. We will walk through the essential steps to set up your development environment and run a simple JavaScript file. First, you should download the LTS or long-term support version of Node.js from its official website. This ensures you get a stable release, which is recommended for most development projects. After installation, verify that Node.js is correctly set up on your system by using a simple terminal command. Type node-v in your terminal and it should display the installed Node.js version. It is also important to verify the installation of npm, Node Package Manager, which comes with Node.js. Use the command npm-v to confirm its presence and version, as it is crucial for managing packages. Now, create a simple JavaScript file, perhaps named app.js, to write your first Node.js program. In app.js, you can add a console.log statement to print hello Node.js to the console. To run this JavaScript file, simply use the Node.js runtime environment by typing a command in your terminal. Execute node-app.js and you will see hello Node.js printed, confirming your successful setup. Let's explore the essential core modules in Node.js that provide fundamental functionalities for your applications. These built-in modules offer a wide array of functionalities, helping you perform diverse tasks efficiently in your backend. First, We have the FS module, which is crucial for interacting with your computer's file system. This module effectively handles various file system operations, allowing you to manage files and directories programmatically. You can use the FS module to perform essential actions like reading, writing, and modifying files on your system. For instance, fs.write file sync writes data, while fs.read file sync reads content from a file. Next, the HTTP module is fundamental for network communication, especially for building web servers. It allows you to create a simple web server that can listen for incoming requests and send responses. This module efficiently manages HTTP requests and responses, forming the backbone of any web application. Therefore, the HTTP module is absolutely essential for building robust and scalable web applications in Node. JS. The path module is designed to help you work with file and directory paths in a consistent manner. It greatly simplifies the process of working with file paths, making your code more portable across operating systems. You can use it to join path segments together or resolve absolute paths, ensuring correct file locations. For example, path.basename extracts the file name and path.join concatenates path segments. The OS module provides useful methods for interacting with the operating system itself. It provides various details about the operating system such as its type, architecture, and uptime. You can retrieve platform information like Win32s or Linux and also details about available memory. For instance, os.platform gets the operating system and os.freemem reports available system memory. In this section, we will focus on NPM, Node Package Manager, for efficient package management. We will learn how to manage dependencies effectively within your node. JS projects, which is a crucial skill to initialize a node. JS project. You will use a command that quickly sets up your project's basic structure. The npm init-y command creates a package.json file which stores project metadata and manages dependencies. Simply type npm init-y in your terminal to create the package.json file automatically. Here is an example of a package.json file which outlines the project's essential configuration. This file lists the project name, version, and scripts, while the dependency section tracks all installed packages. This is an example of the package.json structure, showing fields for name, version, scripts, and dependencies. When you need to add new functionalities, you will use npm to install the necessary packages. The npm install command adds third-party libraries to your project, saving them to the dependencies section by default. For example, you can install the Express framework by simply typing npm install express in your terminal. Sometimes, you need packages only for development purposes, which are called development dependencies. The npm install -save-dev command installs packages exclusively for development, listing them under dev dependencies. For instance, to install Nodemon as a development dependency, you would use npm install nodemon -save-dev. Now, let us introduce Express. JS, a minimal and flexible web framework for Node. JS backend development. Express. JS simplifies building robust and scalable APIs, making it a popular choice for the MERN stack. Express. JS offers a minimal setup, allowing for quick and straightforward configuration when handling HTTP requests. This simplicity helps you get your server up and running very quickly, focusing on core logic. It comes with built-in middleware, which efficiently processes incoming requests before they reach your final route handlers. This middleware system allows you to add functionalities like logging, authentication, and passing request bodies with ease. Express.js provides excellent RESTful API support, making it ideal for building robust and well-structured APIs. You can define routes for GET, POST, PUT, and DELETE requests, aligning with standard REST principles. It offers seamless database integration, allowing you to easily connect with various databases like MongoDB. This flexibility ensures that your backend can interact with your chosen data storage solution efficiently. Express.js is highly capable of building scalable applications and is widely used in production for high-traffic environments. Its performance and flexibility make it a reliable choice for applications that need to handle many users. Now, let's explore the standard HTTP methods used in RESTful API design for interacting with resources. These methods define the standard operations for how clients interact with data or resources on a server. The GET method is primarily used to retrieve data from the server without modifying it. It's a safe and idempotent operation, meaning it doesn't change server state and can be repeated. For example, sending a GET request to the /users endpoint will fetch a list of all users. The POST method is used to create new data or submit information to the server. When you want to add a new resource, like a new user, POST is the appropriate method. For instance, a POST request to /users with user data will create a new user entry. The PUT method is used to update existing data on the server, typically by replacing an entire resource. You use PUT when you want to modify an existing resource, providing the complete updated representation. For example, put to /users/ID updates a specific user's information by their ID. As its name suggests, the delete method is used to remove data from the server. When a resource is no longer needed, a delete request will permanently remove it from the system. For example, delete to /users/ID will remove the user corresponding to that specific ID. Let's delve into the different types of middleware available in Express. JS, crucial for request processing. Middleware functions enhance your application's request processing capabilities by executing code at various stages. First, we have built-in middleware, which comes directly with the Express JS framework itself. These functions are pre-packaged with Express JS, providing common functionalities without requiring extra installations. For instance, Express.json is used to parse incoming JSON request bodies effectively. Another example is Express.static, which is perfect for serving static assets like CSS or images. Next, we look at third-party middleware, which you can install to extend Express JS. These are typically installed via NPM, allowing you to add specialized features to your application. For example, the MERN middleware is widely used for logging HTTP requests in your console. Another popular one is CORS, which handles cross-origin resource sharing, enabling secure communication between domains. Finally, you can create custom middleware, tailored specifically for your application's unique needs. These are user-defined functions that you write to perform very specific tasks within your request pipeline. Custom middleware can be used for various purposes, such as logging requests or handling user authentication. Importantly, custom middleware executes before the final route handler, allowing pre-processing of requests. In this section, we will implement JWT authentication, securing RESTful APIs with JSON Web Tokens. We will walk through the steps to set up user registration, login, and protect clouds using JWT. First, install the necessary packages for JWT, password hashing, and environment variables using NPM. You will install Express, JSON Web Token, bcrypt.js, and .env to handle authentication and secure data. Next, create a register API endpoint that securely hashes user passwords before storing them in your database. This code snippet shows how to define a post route for register, hash the password, and save the user. Then, implement a login API endpoint that verifies user credentials and generates a JWT token upon successful authentication. Here, we compare the provided password with the hashed password and sign a JWT token if they match. Finally, protect your API routes by creating and applying an authentication middleware that validates the JWT token. This middleware extracts and verifies the JWT token from the request header, granting access only if it is valid. To conclude, let us summarize the key takeaways from our discussions on Node, JS and Express, JS backend development. These points highlight the most important concepts and benefits of using these technologies for your projects. Node.js is a powerful JavaScript runtime environment primarily designed for efficient server-side development and execution. Its event-driven and non-blocking I/O architecture is crucial for ensuring high scalability and performance. NPM, is an indispensable tool for managing project dependencies and easily installing various packages. Express. JS simplifies the process of building RESTful APIs by providing robust routing and middleware capabilities. Middleware is essential for enhancing request processing, enabling functionalities like logging, authentication, and error handling. JWT and OAuth are vital for securing APIs, ensuring proper user authentication and authorization.